So, ladies and gentlemen, we have with us the COO and CTO, National Stock Exchange of India, Shiv Kumar Bhasin. Please get your hands together, ladies and gentlemen, as Shri Shiv Kumar Bhasin joins us on stage. He's going to be speaking about best practices from disaster recovery principles and strategies for ensuring better business continuity.
Hi, good afternoon, everyone. So I thought that this was initially I thought this must be some kind of a panel discussion or some interactive session. But since now I have been, shared the practices for the disaster recovery and business continuity. So I will share the case study which we have implemented in National Stock Exchange. So as you know, I work for National Stock Exchange. And last year we were given the task that by the regulator, we had a RTO, RPO as usual. I think most of the financial services organizations have 4 hours and of a RTO, and sometimes some regulators have 15 minutes of RPO, some regulators have half an hour, 30 minutes of RPO, and the target was given to us that we have to 4 hours needs to be reduced to 45 minutes, and most of our processes before this target was given were really meeting like 3.5 hours. We were nowhere close to even 45 minutes or 1 hour or anything that we can say for sure this we can go ahead and implement it. And the time given to us was a quarter. Like first week of April, we got the notification last year from the regulator, and by the end of June, 27th or 29th of June, if I still remember, we were supposed to declare that we are fully compliant, with this. And no one around the globe, when we started looking at the stock exchanges around the globe, nobody had a better than 2 hours. Most of the people were doing 3 hours and few were 2 hours, and otherwise in general there were 4 hours as standard category. But 50% people, 50% exchanges had 3 hours, and approximately 25-30% people were at 2 hour kind of a RTO. And that when we looked at the kind of those exchanges they were not like huge volumes who were handling. So we had a challenge always that our volumes have been during the COVID times have been exponentially going very, very high. Like when we entered into the COVID, we were handling 2 billion orders in a day. And today we handle 12 billion orders, 6 times. And 3 years back, if we go, we were handling less than 1 billion. So in 3 years, there has been a tremendous growth, nearly 1 billion to now 12 billion. So keeping the systems, scalable and preventing the data loss for such high volume. And this target was given not within intraday. It is not like you are off the business hours. These RTO, RPO needs to be maintained during the business hours from 9:15 to 3:30, which is the market hours. That the next session, if the disaster hits, should be started in 1 hour, which is 45 minutes of the technology switchover and 15 minutes of the pre-market. And hence the market can be restored in 1 hour. And nobody, if you look at the last 2 years or now 2.5 years of the statistics across the globe, there have been around 24 outages across multiple exchanges, and none of the outages were having a restoration on the same day. Some people restored the market very next business day. Some people had a larger outages as well, like couple of days. And the outages reason was also varying. Like sometimes it was a some technology glitch, but sometimes it was a cyber attack as well, which crippled their systems and they were out of the business for 2-3 days or sometime 24 hours. So, given this challenge, we first what we did actually, or that we needed to classify our applications. Earlier, we had a subconscious, not a very formal way of categorizing the applications like a tier 1, tier 2, tier 3 based on their business criticality. But we really had a greater relook at the entire set of applications, and we classified them into these categories. And within the application as well, like for example, I will take example again for the trading platform. In trading, as you know, there are multiple segments. So some of the segments are huge voluminous segments, and some of the segments are like average or low volume segments. So each segments needed a very different mechanism to restore. And a lot of our applications were using standard solution as a storage replication. And storage replication also had a challenge that whenever you you switch over, there used to be the largest impedance in terms of switching over used to be the mounting the servers from one storage to other storage. That was the largest time-taking activity when we did the drill down, that where we are losing most of the times, to bring it down to shorter times. So first thing we did that we classified the applications under the business criticality levels. Second thing, we said that given such criticality we have, where we have to have a guaranteed 45 minutes restoration, and it requires, like, see, we are not alone, neither banks or any financial institutions. You have to integrate with the ecosystem. When you say that 45 minutes I will restore the services, you should be able to restore your connectivities, integrations with the ecosystem as well. Otherwise, you're not restoring the service back. So challenge for us was that we cut down the target from 45 minutes to 30 minutes to the technology teams, because last 15 minutes were set up or left so that we can have any kind of a dialogue with the third party if some of the connections are not restored in the first 30 minutes. And we have pre-market time window as well for some of the connectivity. So we effectively get, although half an hour, but target is like we still have to declare in 45 minutes we are 100% there. So all our systems should be recoverable in 30 minutes. That was the target we set up for ourselves. And after classifying these applications, when we looked at how we are setting up the replication, how are we replicating the data from one side to other side, and how we are having a data loss prevention mechanisms, like a lot of us have a near DR site. And there was I will further discuss down the line, there was another challenge is now there right now with us, where the regulator is saying that you have switched over to the DR in say at 11 o'clock, and again disaster hits at the DR as well. So you should be again you should be able to switch it back in 45 minutes with a similar kind of a SLA, only with no similar near zero data loss as well. So that is a problem we are solving now again, but I will go there later. So the first thing was that we classified these, and then we identified what is the replication mechanism across each application, across sites. And a lot of applications being storage based, we decided first that they should be getting migrated to the host based replication, or the real time message streaming across all the three sites, which is the near DR as the far DR. And we did the POCs with both in first 30 days. Real-time message streaming, we adopted the low latency, high throughput middleware solutions, proprietary middleware solutions. And for the host-based replication, there are many popular, OEMs are there. I will not take any OEM's name in any mechanism, but so we did host and message streaming based, and finally we chose message streaming, real-time message streaming based, solution. So there, the main challenge was all the time. Our challenges were getting compounded because the exchange market is interoperable as well. Like interoperability went live 2 years back, where the trades are coming, from the other exchanges as well to the clearing corporations. So this guidelines of 45 minutes was across exchange and clearing corporations both. So all the systems, and clearing corporation systems were largely using the databases, while the our exchange systems are largely in-memory based systems. And everyone was using storage as one common theme. And where, like in memory, they were taking a dump into some kind of files, and then the storage was getting replicated, which was having a severe latencies were caused because of the RTO was quite, luxurious enough for us to maintain that kind of a SLA. While given this aggressive SLA, there was no other option that all the messages are continuously, whatever we are doing at a production, we had to keep the near DR and the far DR systems hot. And we decided to keep, and in our case, like a lot of people go for the two-phase commit. So we can't go for that as well, because we are latency sensitive business. So the minute we say that we are going to first replicate the transaction in near DR, and then we will release the transaction to the the production to the end user system, which is normally the broker systems, it is going to add huge latency, because we are working in such a microsecond latencies, and even if the near DR is 5 kilometer apart, but still it will add 1 to 3 millisecond of latency in any transaction. So that was not an option that we can use the two-phase commit and then we can go ahead, we can ensure. So we needed a really a innovative solution that where we go for a ultra low latency middleware and we go for asynchronous replication across sites. So that's got implemented for the trading and risk systems, which are the key to restore the market. And in both the cases, we started doing the compression of the messages. So one thing, we wanted to beat the geographic latency as well. So one thing we did, that first, we are not sending all these messages the way the messages were getting formed originally. First, we compress them further. We are anyway, being a latency sensitive business, our packet sizes are not as high as like normal BFSI industry. We always deal with a few bytes of data, 400 bytes to 900 bytes of data. And further that got compressed, and then we were transmitting these messages to the near and far site to beat any latency overheads and the geographic latency overheads and all. And the results were phenomenal, that in case of our equity market and some of the other markets which are the low volume markets, equity is medium, but F&O is a very, very high volume. Like if we have today 12 billion orders in a day we process, total across all asset classes, the 10 billion orders come for the F&O. So that was our biggest challenge, that how do we replicate all the trades, and order trade ratio is 1:100. So, and that is where, because each order size can vary. One order value could be much higher because number of units and all could be. It's in our case in FNO, especially the algo traders, which is their field, and they can have in one order could be running into millions of dollars as well. So when we did this tuning of the platforms and we got the outcome of we had a near zero data loss for the equity market and SLB market. And when I say near zero, which was really, getting into 10 to the power minus 9 levels of the, order loss, or, packet loss and all. So, which was negligible. But when we went to the FNO, there we had still a order loss in the range of 10 to the power minus 2 to 10 to the power minus 3. So in that range, and then if you look at the transition period of from the time the disaster hits and from the time we kick in our 45 minutes automated switchover failover mechanism, that could be a couple of minutes of where we will remain behind. That could be the only loss, and with that we were still when we finite way, because we did the performance engineering test for that, and we found we were losing only 1700 to 3000 orders only in FNO, and other places, as I said, there were almost like 17 trades in the SLB and maybe 40 to 90 trades, 90 loss only in equity, if at all. And if it is we are lucky that volumes are not high, they will directly go to the equity, and SLB will definitely go to the near zero, while 3000 number or 1700 to 3000 number can come down to still 1200. But 1200 trades loss is still a high loss, but that's the best in the industry we could have, because when we did the benchmarking with some of the other MIIs, they had a more severe losses than this. And the way our mechanism is that exchange declares that this is the last trade received, this is the last trade processed, then any other trades which are after that and have gone to the market, they are considered null and void, and this is acceptable by regulator as well. But what we showed in this, that if we go for a host-based replication, if we go for the replication using the storage, then it will be losses may go into as if you are processing 10 billion, the losses could be as high as that going to 500,000 loss of the order packets and all. So from there, if we are saying that using this mechanism, we are restricting it to 1700 to 3000 packets only. So that was the kind of a preventing the minimizing the loss for the market. Although regulator had that request that we should do the two-phase commit. And given our nature of business, that if we do that, everything guaranteed like that, so the latencies will be way high for the market, and market will suffer. And this debate is anyway going on in the regulator circles. That no one probably they have woken up now and thinking that probably no one is doing in the industry in the exchange market the two-phase commit, because either we give the preference to the data loss and latency sensitiveness, or we go for the 100% insurance. So what do we need actually? So these are the trade-offs we have to handle. The second part of the problem, which was the NCL systems or the clearing corporation systems, were lot simpler that way, if I say, because they were using databases, but they were not using a lot of optimized way of leveraging the databases for preventing the data loss. So there we went from a storage replication to the the multi-site replication, like forward replication. We have the relay mechanism we have used. So we are first replicating it to the near DR, and near DR is sending the messages to the asynchronously to the far DR, so that we have a near DR, the full minimal loss and all. So that also, there also we have a close to near zero data loss, where we have brought down the latencies to around 13 to 14 millisecond of the between the production and DR. Our Oracle data loss is around 14 millisecond, not more than that. And we have to do a lot of network upgrades as well for carrying out these exercises. But classification of the application was one of the key, and the real-time messaging means we ended up doing this custom host replication using the optimized low latency messaging, and that was one of the first means what I hear from the different solution provider. This is one of the unique solutions used by the any of the organization. But normally people end up leveraging some kind of a DR replication tools like SRM, and all various tools are available in the market. So this is a complete custom mechanism on the real-time application side. And one of the key learning has been also that how to design you have to understand your interfaces very, very well, external and internal, because there was a requirement that we can restore the segments as well. And there was a challenge given to us that in 45 minutes, it may be the case that not the whole DR you have to migrate, but if you have only FNO trading platform has clunked, so we should be able to migrate that only that platform to the DR, while rest of the trading is happening from production. So that segment level failovers were also we were asked to prepare. So we did that as well. Like we did for FNO. In the first iteration we proven that to them, and once they saw it results from us, they got it amended their circular as well, and they asked us to prove for rest of the segments as well. When I say they, means regulators. And so their learnings have been that a lot of times you will find that the way developers today write the code, that where the stateless protocol is not maintained while integrating the various systems, there are a lot of file batch handoffs and all. So given business scenario to scenario, you have to focus on how your interfaces are designed, and that actually knowledge of the interfaces and knowledge of the system, then implementing your automation software. Like you can use various industry automation softwares, like there are many, again without taking names, all of them, all of you must be using them as well. So we have also used one of those popular replication DR switchover softwares only. But ultimately, homework which is required for determining the sequencing of the applications which need to be migrated, in which order the applications need to be migrated, switch over to the site, as well as the interfaces, their dependencies. So that is very important. Otherwise, any tighter deadlines of switchovers cannot be maintained. And I am very happy now we set up the target for 30 minutes for the team, but ultimately when we have done, which we are publishing every quarter now to the SEBI, all our trading and risk platforms are switching over in less than 3 to 5 minutes to the DR. And entire end-to-end, all critical, non-critical platforms across all tiers and layers of the applications, we are able to switch over in 23 minutes. And it varies actually. We have done fastest time was the 17 minutes. So 17 to 23 minutes varies on some of the day of the peak days and all various things. Some other factors are also there. But 23 minutes we are able to do, including all non-critical system. Although I'm very happy that we do the trading and risk system in less than 5 minutes or 5 minutes. we have 40 minutes now to mitigate other things, or to talk to the ecosystem across the, like, where we have other MIs, NSDLs, means the depositories and all, everyone. Their interfaces also have to work with us to have a successful turnaround time. So I think a lot of headroom we built like that, and some of these learnings I thought I will share with you. And as I said earlier, now we are working on solving the problem that when we go to the DR, and then again the disaster hits there as well. Means we are so unlucky. After switch over to DR, again DR also gets into a problem. So, and now we know the production is healthy. So how to switch it back on the same day, on the same working day, with the same SLA of 45 minutes, and with the similar kind of a near zero data loss. So what we are doing, it is just we are replicating the solution, identical solution, to the DR as well, where we are setting up a near DR for DR. So now we are, all in all, we are setting up a 4 DC implementation in a nutshell. So this 4 DC, I know maybe some of the banks are also thinking, maybe it's one of the bank has already might have implemented as well. But with this kind of stricter SLAs, so we are implementing, and this is we are planning to go live with it by September time frame. There is no, right now no deadline as such, but this is more into the regulatory circle. They are discussing all these things. So we just, this time we don't want to stay back and relax, and when the regulatory circular comes with deadlines, and then we are rushing about. So we are just doing little more proactive step to go for the 4 DC implementation. So this I just wanted to share, because Shrikant was asking that I must write about something, and I thought maybe before I write or anything like any such paper, but it will be good to interact with the people, and they can also share some of the their experiences or any questions. So that interactive session will be very good. Thank you. Any questions you have, please?
Sure. So we have time for a couple of questions only. So I'll come to you, sir.
I think such questions can be asked only to the people who are handling such complex. This is Sanjeevan from UTI Mutual Fund. I had information security and also infrastructure for UTI. He is always saying something should be thought out of the box, right?
Right.
And the questions out of the box has to come to you, because you're handling a very, very complex infra. So you were mentioning about real-time information you're putting on the memory.
Yeah.
And then you might be shuffling into the disk.
Right.
Because that is where, the real-time, a millisecond trade, where it resides.
Right.
Do you feel that there is some limitations on the technology to meet your requirement? Just concentrate on that area, storage and memory, because others we understand. And whether memory replication can help you to overcome your limitations.
See, memory replication is actually within the, we use resilient platform, like we use Stratus platform for our trading applications to run. So everything is 100% redundant at a hardware level, software level in this Stratus implementation. So we do the complete in-memory is replicated as a HA node. Within the same, we have a resiliency, like for everything we have a, when I say resiliency, so like you have a N+1, implementations of any application, we also have. But within the same node as well, each node is highly resilient, the way the Stratus platform works. So in spite of having a first of all, the entire Stratus box has to go down, including its resiliency, which is built into its proprietary hardware. Then only we will go to the second node. We don't use active. It is a more active standby. So which is it's not a cold standby. It is a hot standby. It can always switch over in fractions of seconds. But within the same box as well, like if I have some of the CPUs clunk, seamlessly the standby CPUs take over I don't even come to know. No blip comes in our monitoring tools as well, the way status platform it is designed. So within the same site, all this, as you are saying that in memory, we are doing all that replication in place. But this is the cross site. So cross site, when you have to send the data, you right now so far no one has implemented any in memory. So that's where we have designed our. So we are not taking the data from the disk to do the mesh-based replication. We are not, without storing the data to the local disk, the data is getting streamed in a real time to the near site and far site. No persistence is happening at all. The persistence happens, post the execution of the transaction. So so those latencies we have already cut off actually.
Right. Unfortunately, due to lack of time, we will not be able to take another question. Sir, it was absolutely amazing. Thank you very much for joining us out here. Can we have a huge round of applause, ladies and gentlemen?